Sorry, I almost forgot that too. All right, so the first thing that we're going to do is graph this linear inequality system. It's linear because they're single x's. We learned that in Unit 1. So how do I graph 4 minus x? If you want to, you can flip it around to be negative x plus 4. How do I graph that? Come on, guys.
It's at the 4 is the y-intercept.
You are correct.
And then it's, instead of going from left to right, it's right to left.
So just make sure it's decreasing and it's 1 over 1. Do not color it in yet. Do not color it in. I just made the dots. Remember that this inequality tells you 2 things. It tells you where to shade, and it tells you if it's solid or dashed. Okay, so if it has a line, it will be a solid line. Okay, so solid happens when it's less than or equal to or greater than or equal to. Dashed happens when it's just less than or greater than. So we are going to make it solid. And then if we want to know where to shade it, I always tell people to plug in 0, 0 to be 100% sure. So if we plug in 0, 0. And the reason I chose 0, 0 is because it's not on the line. And it's the easiest point to plug in, not on the line. So what's 4 minus 0?
4.
Is 0 less than or equal to 4? Yes.
Yes.
So you shade where 0, 0 is. And do a light shade because we're going to do a second shade as well. Oh, I thought I had a red pen up here. All right. All right, check out the next one. 2x minus 3. How do I graph that?
Negative 3 is your y-intercept.
And how do I move?
Up 2 over 1.
Yep, 2 over 1. Is this one solid or dashed? It is dashed because it's not equal to. So the way that I dash it is I connect 2 dots and then I skip. Connect 2 dots, skip, connect, skip. So it looks like this. It just makes it a little easier than having to draw it and erase it or whatever else you guys have learned to do. All right, it doesn't go through 0, 0, so I'm going to plug it in again. I have 0 is greater than 2 times 0 minus 3. Again, I chose 0, 0 because it is not on the line and it is super easy to plug in. What's 2 times 0?
0.
Minus 3.
Negative 3.
Is 0 greater than negative 3? Yes, so the true statement means you shade where 0, 0 is. So I'm shading this side. And then your solution is where they both cross. So where all that shade intersects. Now realize that's not the only place it extends all the way out. As the graph gets bigger, that'll extend outside of those square wall boundaries, okay? But that's exactly how you do it. Now these are 2 linears. What you're going to see is we're going to work on nonlinear. So we're going to have quadratics and we're going to have exponentials and we're going to have absolute values, okay? So remember how to graph those. We're going to go back to Unit 1 and how to graph those. So if we look at example 2, what type of functions do we have?
Quadratic.
Quadratic and?
Exponential.
Exponential. So what is the shape of a quadratic? So we should have a U on our paper. What's the shape of an exponential? It's like a Nike check. That's exactly what I call it. That's just the way that I remember it. It's like a Nike check. So it's just a curve. So don't forget that those 2 things are what you have to have. So I'm really lazy and it's okay to be that way. So if you don't have a calculator, if you're sitting in here and you want to grab one, go ahead and grab one. But if you do have your calculator, go ahead and pull it out. If you have anything in your calculator, you can go ahead and clear that out. I do want you to graph it on your paper, okay? I do want you to graph it on your paper. That means we need to figure out what our points are. So I'm going to plug it in, negative x squared plus 1. And I'm just going to work on the first one. Is it solid or dashed?
Dashed.
Good. Okay, so I'm going to check those points out. So my table, and my table starts ridiculously high for right now. 1, 2, 3, 4, 5, 6, 7. I can only go to 7. So -2, -3, I can graph. -1, 0, I can graph. 0, 1, 1, 0. So we can see it. You said it was dashed. Oh, sorry, I didn't mean to make an arrow on there. And we just do the best we can with these dashes. I'm not like super freaked out about them or anything like that. So just make it so I can tell that they are dashed, okay? All right, now watch this. I don't know if you've been taught this or not. If we go back into y equals, and we move over to this blue square, does everybody see it? And we hit enter, we can change that line. This is just the line, a regular line. This arrow pointing up means greater than. What is our inequality? Less than. So move it over one more time and it points down. So if it's pointing down, that is less than. And then we can just hit graph and see, is the shade on this side or that side of the graph? Zoom 6, sorry y'all, I'm still zoomed in for stats. Zoom 6. And where is the shade? Why did it not shade it for me? I didn't hit enter, sorry. Okay, graph. Now, where's the shade? Inside it or below it? So I'm going to make a very light shade inside. I'm going to go back into y equals and clear this all out. If I hit clear enough times, it'll clear everything. Okay. I'm going to put my exponential in. 2 to the x minus 3. What is that? Is everybody good? 2 to the x minus 3. Check out my points. I'm going to graph anything that I can. I have a 0, -2. Let me do it in black. I have 1, -1. I have 2, 1. I have 3, 1, 2, 3, 4, 5. As good as it's going to get this way. I can try to do the -1 and stuff like that, but what are you starting to see? What's happening? What happens there? What's that?
They never go past -3.
Yeah, what's that called?
Boundary point.
No, no, close. It is a boundary point. You can't go past it, but what is that thing called?
The asymptote.
Yes, an asymptote. So that'll help me graph this. And is it solid or dashed?
Solid.
Good. Why is it solid?
There's equal to.
So I'm gonna get as close to that line as possible. And then I'm gonna follow up with my points. And then because I'm lazy, I'm gonna go back out here. And we still have less than, so I'm gonna change it to less than, and this time I promise I'm gonna get it right because I'm gonna hit okay. Is everybody good? Because again, I can be lazy. And I'm gonna graph it. And where's my shade?
Below it.
So it's all through here. So the place where all of the shade is underneath this curve and underneath the U shape. So just that little area right there. Does that make sense? Is everybody good? Karis, you can move if you need to. Okay. Everybody good? All right. Let's check out our next one. If y'all have any questions, you got to let me know. That's basically all we're doing. Y'all, that's what we're doing this whole day, okay? When you do your quiz, it's going to have to be on paper. If you don't have these printed out, you can use graph paper, or you can, I mean, it's going to be real hard to sketch these and make them look good, okay? So try to find some graph paper or something. But if you have been in class or are in class right now, you have the quiz. So you just do your quiz like normal and upload the picture of the quiz. Okay. All right. Number 3. What are these?
Absolute value.
Absolute value. Absolute value is what shape?
A V.
What about this one? It's upside down.
It's-
Is everybody good? Yeah. It's upside down. So this one will be like a mountain, and this one will be an actual V shape. Okay. Is this one solid or dashed? Solid. What about the second one? Dashed. Okay. So we're going to put it in our calculator. I could do this one by hand and be okay, but we're going to go ahead and do it in our calculator just to keep it normal. Math, absolute value. So math over to num, your absolute value bars. I'd already put my negative in. X plus 1. And I'm going to check out my points. I went way up to show you guys that one. I think 7 is as good as we can get. -8, -7 we can't do. -7, -6. Yep. And then we have -6, -5. And then we have -4, -3. I'm sorry, not -4, -3. -5, -4, -4, -4, -3. -3, -2, -2, -1. -1, 0. And then it goes back down. So there's your peak, and now you can get your pattern or your max, whatever you want to call it. And you said it was solid. Absolute values and quadratics are really easy. I'm not even going to graph this one because if it's greater than, it's above, and if it's less than, it's below. So above the mountain or below the mountain. Does that make sense? Above the U or below the U. So this one is above. So that means we're shading this part right here. Okay. We're going to do our other one, 2, math, num, absolute value of x minus 2. And in our table, -4, 6. -3, 4. -2, 2. -1, 0, which is the same point we have here. 0, -2. 1, 0. And then you should be able to see the pattern. It is dashed. I do this one just like the linear. And I skip. And then it says less than, so that's below the V. And this one actually has 2 places. This triangle right here. And this one right here. Is everybody okay? All right, what's really cool is you actually can do these in your calculator together. You absolutely can. The only thing your calculator will not show you is it can't do the shade and the dash at the same time. So it'll do the dash and solid, but you don't really need to know that. What you need to know is where the shade's at to see if you got it right. So I'm going to put the other one back in just to show you. You do not have to do this. I'm just showing you. X plus 1. The second one was less than. So I'm going to change it to less than. The first one was greater than. And then when I graph it on my regular screen, there's the first one that we did. I mean, sorry, that's the second one we did. There's the first one we did. And then you can see better the 2 triangles. It kind of turns a little bit purpley because they mix the red and the red and the blue. Is everybody good? So you can use your calculator to check to make sure. When you take your test, I'm pretty sure it's going to be multiple choice. Just put them in and look at your calculator. The only thing they can't tell is whether it's solid or dashed. But we knew the upside down one was what? Solid. The right side up one was dashed. So you can pick that out looking at multiple choice, okay? All right, look at your next one. What two kind of functions do I have here? Exponential and linear. So our exponential is 2 to the x minus 1. Is it solid or dashed? Ooh. Solid. We have some 0, 0. We have 1, 1, 2, 3, 3, 7. Where does it go to? Where's our asymptote? Where's our asymptote?
-1.
Negative 1.
So we don't want to touch -1. It is solid. It does say greater than. You can do that if you want to. You should know on this one what is greater than. Sorry, graph it. It's going to be above. That is always the case. It'll be above the line. When I graph my other one, I start at -1. Then I go down 1 and over 2. Up 1 and over 2. And this one is dashed because it's not equal. If I don't remember what it is, -1/2, let me do it this way. -1/2 x minus 1. And it says less than, so I'm gonna change it and I'm gonna graph it. So just in case I don't know where my shade should be. So there's only one little tiny place where they match up. Any questions? All right, how do I graph y equals -2 on number 6? How do I graph that?
It's just a horizontal line.
Yes. We're not going to graph it. I just want to remind you that it's horizontal. Okay. Check out the next page. If I were teaching regulars, I would not do 7, 10, or 11, but I'm going to do those with you. It's just 3 graphs. It's no different. I'm going to use 3 different colors so that you can see it. Okay. All right. You can do it on your calculator. It's not a big deal. The only thing you cannot do on your calculator is on number 11. You cannot put in x equals. Okay. So that's the only one. You just have to know how to graph those. So we're going to start with number 7, and these are not that bad. They're really not. They just seem like they are. How do I graph y is less than 4? First of all, we know it's going to be a what? What kind of line?
Horizontal.
Horizontal. Is it going to be solid or dashed?
Dashed.
Good. So dashed at 4. I'll try to make it big for you so you can see it. And it says less than, so where do you think I would go?
Below.
Below. So what I'm going to do is do all my highlighters this time. So that way it's not like blending in too much. You'll see different colors. All right, so that's your first one. The next one is what kind of function? Come on, guys.
Exponential.
Yeah, exponential. I'm going to put it in my calculator, not that I need it, but I'm going to try. I'm way too far down. There's some good coordinates. 0, 1, 1, 2, 2, 4, 3, 8. I can't get on there. It's 1 above. I'll just put it up there just for you. Where is my asymptote? 0. Y'all see these -4s and -5s, the E? Anytime you see E and a negative number, that's scientific notation. Times 10 to the -4, times 10 to the -5. That means we take that decimal and move it to the left 4 or 5 times. That rounds to 0. So your calculator is so precise that it won't put 0. Everybody understand that? So anytime you see that E, -4, -5, anything like that, automatically put 0. So our asymptote is at 0. Is this one solid or dashed?
Solid.
Solid. So I'm going to get as close as I can. And I'm going to connect my point. And it is less than. So I'm going to shade below so you can see it turned orange. And then the last one is just a linear. It's going to also be dashed. Okay. You start at 0, then it's negative, so I go down 1 over 1. Again, dashed. Just as long as I can tell it's dashed, it doesn't matter what it looks like. And then if you're not sure, you can put it in your calculator. And this one is greater than. And we can see that we shade above. And green. So then where is pink, green, and yellow? It's this part right here. Okay, if it gets confusing, put them all in. We had less than 4. And we had, not that one, sorry. 2 to the X. And we have less than on that one too. And you'll see all 3 colors. So it makes it a little bit easier as well if you'll put it in your calculator just to be able to see it. See? Is everybody good? So again, you shouldn't get these wrong because you have to graph them on your homework, but I mean on your quiz or whatever, but I do not think that you have to do it on your test. We haven't really made it, so I don't know. It'll be whatever Miss Gordon and I decide together. Okay. Is everybody good? I like multiple choice because I can get it back to you a lot quicker than I can looking at 50 graphs. Okay. All right. Check out number 10. See this X equals? It will not go in your calculator. Don't try to put it in there. What kind of line is that?
Horizontal.
Nope. Vertical. There you go. It's all right. Remember we talked about y equals being horizontal just a second ago. So x equals is vertical, and that is exactly why you can't put it in the calculator because we have y equals, not x equals. Okay. So this one's vertical. It is dashed at -1. It says greater than. If this is -1, is the left greater than or the right greater than? The right.
The right.
Perfect. So we're going to shade to the right. The next one is 2 to the x. And we literally just did that, but this time it's greater than. So we had 0, 1, 1, 2, 2, 4, and 3, 8. It is still solid. So again, this just comes from the last one that we just did. We already graphed it. But this time it's greater than. So we're going up here, and you can see just this little area right in here is what's covered right now. Okay, so our answer will be within this shaded area. Then we graph the other one. We start at 1. We already have a point there. And we go down 1 over 1. It is solid. It is solid. Sorry, y'all, we're almost done. I apologize, guys. and things. So now we need to tell whether it's less than or greater than. How do we graph it? Again, linears are the ones that get a little confusing, but you can do your calculator again. 1 minus x. I'll put it up there in just a minute. 1 minus x, and it's less than. And when we graph it, it's shaded underneath. So where's the only spot that there's 3 shades? Kind of deceiving on mine. Where is it? Where's the spot where there's 3 shades, 3 colors? That little bitty tiny spot in the middle. That's where your answer is. So what that means, that little tiny spot in the middle, is that every value within that little shaded area will work in every one of these inequalities. It will be greater than -1. It will be greater than or equal to, plug in the x, the y, whatever. So it will fit and make all of these equations true, okay? One more and we're done. This one's easy because it's got zeros in it. Y is less than 0. Where am I graphing that?
0.
X-axis or Y-axis?
The X.
Yeah, it's the X-axis. And it is dashed. Watch your shading. So here, I'm going to try to make it bigger. It is dashed. So I'm just kind of sitting it on the line so you guys can see it a little better. And it says less than, so where do I shade? Below. Okay. I'm going to go ahead and do the other 0 because it's pretty easy, right? So I'm going to do it. So that's the y-axis. I'm going to do this one. And it's solid. So I'm going to try to just darken it up a little bit so you guys can see it. It's actually the axis. Looks pretty good on my computer. It don't look very good anywhere else. And then if it's greater than, which side am I shading? The right. So now that box, what quadrant is that? Ooh, what quadrant?
4th one.
4th. Very good. Remember, it goes 1, 2, 3, 4. All right. So then the last one is 2 minus the absolute value of x. If you need your coordinates, go ahead and get those. Y equals, clear all that crap out, 2 minus absolute value of x. Get my coordinates. -7, -5. -6, -4. -5, -3. -4, -2. -3, -1, -2, 0. -1, 1. 0, 2. And then it goes back down 1, 1. So as soon as you find that peak or that top point, the vertex, you can move down. It is solid. And if it is less than, where do I shade? Below it, underneath it. So then where are your 3 shades at? They are this crazy shape in the 4th quadrant. Is everybody good? Good? All right, I'm gonna stop there. I'm not gonna do any more. If you have more questions and you wanna stay on the Zoom, we might run out of time, but we'll come back in. So I'm gonna stop share, stop recording.